this lecture, let us discuss about some real-world applications of NLP. So we already saw in our previous lecture that NLP is a subfield of AI, which mainly focus on interaction between computers and human language. And the main goal of NLP is to enable machines to comprehend, interpret, and generate text in a manner that mimics human language understanding, right? So here we'll see some applications. These are the top most 10 NLP techniques used in the industry. So we'll discuss all these applications one by one. Before that, so this is how these tasks are categorized according to the level of difficulty. So these are the tasks which comes under easy level or the beginner level applications, that is spell checking, keyword based information retrieval, topic modeling. And coming to the medium level, we have information extraction, closed domain conversational agent, text summarization, etc. Coming to the harder level, we have question answering, machine translation, and conversational agent. Then first one is text classification. So we can define this as it is nothing but assigning category to a sentence or document. So best example is spam filtering, right? So we can define this text classification as a process of automatically characterizing the given text into any of the predefined classes or categories. So one best example is you can classify the emails as spam or not spam, as well as whenever a news articles corpus is given to you, then you can categorize the news articles by topic. So this is how classification is done. Whenever the documents are given to the classification system, then it will categorize them. So assume that this is a news article. So it will categorize them according to different categories like art, business, culture, and entertainment. So the first category or the first type of classification is binary, where two mutually exclusive categories, where we'll have only two categories. Example, best example for that is spam detection. Multi-class. So if we have more than two mutually exclusive categories, then that is multi-class classification. So example for this is language detection. Multi-label. So non-mutually exclusive categories like movie genres, it comes under multi-label classification. Some of the applications of which comes under this text classification are sentiment analysis, spam detection, topic classification. First one is sentiment analysis. Sentiment analysis, it always identify polarity of a piece of text, right? So it will try to find out subjective qualities like attitudes, emotions, sarcasm, confusion, suspicion. So all these things will be identified or extracted from the given text. So sentiment analysis, it determines emotional tone or sentiment expressed in the text. So it will identify whether it is a positive sentiment, negative, neutral sentiment, or negative sentiment. And it is widely used in social media monitoring and customer feedback analysis. So here you can see if the sentence is great service, then this word great, it represents it's a positive sentiment. Whereas just book 2 nights at this hotel. So it actually tells us nothing. So it is taken as a neutral one. Horrible service. So horrible itself indicates that it's a negative sentiment. So these components, they form the building blocks of NLP, enabling computers to break down, analyze, and understand the structure and meaning of human language. So given a text sentiment analysis, it will classify the emotional quality. And then, so here you can see there are different ways of using this form of text classification, which include sorting through customer reviews and inquiries and prioritizing negative ones, or monitoring brand sentiment through social media responses, analyzing responses to surveys, etc. So if you take this customer feedback analysis, so companies, they'll use a sentiment analysis to analyze the customer feedback from reviews, or it can be from social media posts or surveys. So by understanding the sentiment behind these comments, business can gain valuable insights into customer satisfaction levels and make the data driven decisions to improve their products or services. Second one is brand monitoring. So sentiment analysis can also be used for brand monitoring purposes. So by analyzing the social media mentions as well as online discussions which are related to one particular brand, companies, they can gauge public perception. And based on the opinion of the public, they'll take appropriate measures in order to maintain or manage their reputation. So in that way, companies are using this sentiment analysis application. Next one is spam detection. So here detecting spam alerts in emails or messages, that is again one of the important application that every big tech company they are using in order to improve their customers or count of their customers. So if you take Apple, so Apple's official messaging app and Google's Gmail, so they are taken as great examples of such applications where spam detection works well to protect users from spam alerts. So here, these are the mails. So the red one, it indicates spam mail, and yellow one, it indicates non-spam mail. So whenever it is given to classifier, it will categorize them into spam and non-spam. So inbox, it contains all the important mails, whereas spam related mails, they'll be sent into the spam folder. Next, topic classification. So this topic classification is a supervised machine learning task which mainly involves assigning a document to one of the predefined set of topics. So the main goal of this topic classification, it is to identify whether the topic of a document, it is related to either politics, sports, or technology. So topic classification, it's again a challenging task because documents, it can be in about multiple topics, right? So here the topics, they can be overlapping or there might be ambiguity. So language used to describe a topic, it can even vary depending on the author and context. So by keeping all these things or by maintaining everything, here topic classification should be done. So this is a collection of multiple topics. After classification, these documents, they are arranged according to the topic. So all the healthcare related documents, they are arranged in the first category: legal documents, tourism documents, pharmaceutical documents. So all of them, they are classified according to their topics. Next, we have information extraction. So here information extraction is nothing but it's a process of extracting structured information from unstructured text sources. So here unstructured text, it can be either news article or web pages. So which includes tasks like named entity recognition, relation extraction, or event extraction. So here information extraction algorithm, it will extract product information also, like price and availability if it is an e-commerce website. And also information extraction is used in variety of industries, including it can be used in e-commerce, finance, healthcare. So everywhere it will extract the structured data from unstructured text. Here you can see what is information extraction. So we have unstructured web text. So this is some text. Assume that it is taken from some source like Wikipedia or anything. So structured sequences, they represent like this. Sign of the zodiac. So all the signs are arranged together. And most common causes of death in America. So the diseases, they are arranged together. Largest rodent in the world. So they are arranged together. So in that way, all the sequences, they are structured or they are arranged accordingly. Next one is question answering. Question answering, it's mainly the task of answering a question in natural language. So building systems that can answer questions posed by the users based on a given context or knowledge base. So we can even define this as it's an NLP task where system accurately answers questions which are asked by the user. So if you take a question answering system which provides answers to simple factoid questions, then questions will be like this: who is the president of United States? Or you can have, so this is a simple factoid question. So there can be more complex ones also where we need more knowledge about the context. So like what factors led to World War II? So here we need to provide a paragraph as answer, right? So whereas here it is just a single word answer, single line answer. So like that, question answering systems, they can answer the questions starting from simple questions to complex questions. And the main goal of question answering systems is to provide accurate and relevant answer to user queries. So development of such systems, they mainly involve deep understanding of both natural language understanding as well as generation. So here you can see one example. See, this is a kind of context-based question. So here we have a context, and from this context, we need to find out the answer for this question. So the given question is, what is the capital of Germany? So we need to find out answer for this question from this context. So answer is the capital of Germany is the city state of Berlin. So this is provided as answer. So applications like chatbots and virtual assistants, they are somewhat similar to this question answering system. And coming to the fourth one, that is machine translation. Machine translation translates the given text from one language to another language. So we can define this as automatically translating the text from one language to another. And machine translation is a process of translating text from one language to other. Actually, both the sentences are same. Say, so for example, machine translation algorithm, it will translate a news article from Spanish to English. So here, sources, article is in Spanish. So that is from one language to another language. That is, we want output in the form of so we want output in English. So what is the task? We want a news article to be translated from Spanish to English. At the same time, machine translation can be used in variety of industries like e-commerce, international business, government. Okay, so some of the popular examples include Google Translate, Microsoft Translator, etc. So here in this picture, you can see source language is English. So if a person say hello, then that text, it is provided as input to this machine translation system, and it should be converted into two different languages. So we want the output to be generated in two different languages. And for this hello, if it is Hindi language, then we should get it as namaste. So something like this. So if you want to produce output in Korean language, so this is the output. So in that way, we can translate text from one language to another language. Next, we have text summarization. So generating concise summaries of longer texts while retaining important information is nothing but text summarization. So here we want only the important information. So instead of maintaining longer text. Okay. So we can take that summary which is present in your textbook. So for the complete lesson, at the end you will find out summary of that lesson, right? Which is either which contains only paragraph or it can have only one or two paragraphs, which explains the important things from the whole lesson or whole unit. So that is nothing but text summarization, right? So it is a process of automatically generating condensed version or short version of a longer piece of text. So if you take a news article, long news article, so from this long article, we want to generate shorter summary by keeping only important points from that article. Text summarization, it is again used in variety of applications. Like you can use it in information retrieval, machine learning, etc. So this is the example. So we are taking a paragraph related to natural language processing, and after summarization, we just got only few lines or few important lines from this document. Then we have named entity recognition. So we can define it as named entity recognition. It is nothing but task of natural language processing in order to identify named entities in a piece of text, or it's a technique which is used to extract entities like people, organization, locations from the unstructured text. So NER model, it works in two-step process. The first step is we need to identify or detect named entities present in the text. And after that, second step is to categorize that entity. So this is achieved by utilizing word vectors and creating context window of these vectors. So the vectors which are generated, they are fed as input to neural network layer, which followed by logistic classifier, which identifies specific entity type. So whether the entity is a location, organization, etc. So if you take this paragraph, here blue, it represents person, location is represented with yellow, organization is black, event, it is green, date is red, others are this purple. So they are again represented with shortcuts P, L, O, E, D, Z. Now, whenever a paragraph is given, then entities are identified, and based on the colors, they are represented in this text. So this Barack Obama is nothing but person, and the date. So August 4, 1961, that's a date. American. So it comes under this other category. United States. It's a location. Again, Democratic Party. It's an organization, right? United States and Illinois, both of them are locations. So in that way, entities are identified or entities are extracted. Next, we have language generation or text generation. So language generation is nothing but creating human-like text output based on given input or prompts. Whereas text generation, it can be defined as process of generating text. So it can be either creating product description or writing news articles. So text generation is again used in various industries like e-commerce, marketing, and content creation. So this is a single sentence for which we are getting multiple lines of text. So best examples for this is chatbot responses or dialogue systems, content generation for written narratives, etc. Next one is speech recognition. So speech recognition is nothing but process of converting the spoken words into written text. Say if I speak something, then the algorithm, it should take my voice as input and it should be converted into text. So spoken commands, they'll be converted into text that can be understood by a computer. So there's a speech recognizer which will take audio of a person, and that audio or speech will be converted in the form of text. Next, text to speech. So it again, it is a reverse, right? It converts the written text into spoken words. So we can use it in applications like speech synthesis, which is especially useful for visually impaired, and voice assistants and automated customer service systems as well. So real life application of the text to speeches, Google text to speech or Amazon Polly, or you can take Apple Siri. So all of them are text to speech. So all these companies, they are using this text to speech. So whenever a text is given, that text will be converted into speech. And the last one is text clustering. So we already know clustering is nothing but grouping of similar objects together. So here, if you combine or group similar text documents together, then that is nothing but text clustering. So one example is, say, suppose if I take collection of news articles and if I group them or arrange them into categories like sports, politics, entertainment. So based on the category, I just arrange them into multiple clusters. So you can see this example. So here I'm having collection of news articles and which are provided as input to this text clustering algorithms, and they will arrange these documents into multiple clusters or multiple groups. So like technology related articles, entertainment related articles, or sports related articles, or it can be politics related articles, anything. So text clustering, it is widely used in variety of applications like information retrieval or machine learning, etc. And apart from this, if you take this chatbots and virtual assistants, so again we have various applications. So this chat the NLP powers chatbots and virtual assistants, which mainly interact with users in a conversational manner, right? So they can be used in various applications like customer support chatbots and websites to popular voice activated virtual assistants on smartphones. Best example is Apple Siri, a virtual assistant which responds to voice commands and questions in natural language. And if you take Alexa, Amazon Alexa, again, it uses NLP in order to understand and fulfill voice commands for various tasks. And customer support chatbots. Many businesses employ chatbots on their websites to provide instant responses to customer inquiries. So everywhere we are using chatbots and virtual assistants like this. So these are few applications in natural language processing.